All right, class, we're going to talk more about quadratic functions today. As you can see, I already have stuff written down, so I want you to take a moment and pause the screen and then write this stuff down. Did you pause the screen yet? Please do that. Okay, so now I'm assuming you're back from pausing the screen. I want to just talk through these things, but I didn't want to talk while you were writing. So standard form is the one we always see. A tells you if it's opening up or down, if it's positive, it's up, negative, it's down. And then we need algebra or calculator to find the vertex or x-intercepts. We need to do negative b over 2a from yesterday, and to get the x-intercepts, we have to factor or use quadratic formula. Vertex form is given as a times x minus h quantity squared plus k, where h comma k is the vertex. We like it in this form to help describe transformations. And all you have to do is find the vertex like we did from yesterday, and then put it in that vertex form, and use the a that was given in the standard form. Now, intercept form is just another name for factored form. Well, actually, I call it also factored form because if it's factorable, you get your x-intercepts. The x-intercepts would be q and p, comma 0. And to get it, you factor from standard form. So let's do some problems. It says rewrite into vertex form and list the transformations in the correct order. So the first thing we need to do is find the vertex. To do that, we need to figure out what our a value, our b value, and our c value. So a is 1, 5. The next thing we need to do is find the vertex. So the x coordinate of the vertex is the opposite of b over 2 times b. So that would be negative 6 over 2, which is negative 3. Now we have to find what the function is at negative 3. That's the y value. So when we put negative 3 in, we get 9 minus 18. That's negative 9 plus 5, negative 4. So the vertex is negative 3, negative 4. So now what you can do is go right to vertex form. If you know the vertex, you can write f of x equals the a value, which is 1, parentheses, x, and then it's the opposite sign of the x coordinate. X is always the opposite. The left is plus 3 squared, it's a square, and then minus 4. This is vertex form. Okay, now we can list the transformations in the correct order. There is a shift left 3, and then the only other transformation is a shift down 4. Okay, why don't you guys try that for this one? You can pause the screen. Otherwise, I'm going to do it right now, where a equals 2, b equals negative 12, and c equals 14. So now I do the same thing, where x is equal to opposite of b, which is negative 12, over 2 times a. So I get 12 over 4, which is 3. And then I have to find f of 3. So I get 2 times 3 squared minus 12 times 3 plus 14. So that's a minus 36, 18, minus 18. So this is another negative 4. Okay. So then we have our vertex at 3 comma negative 4. So that looks very similar to the other equation. So my equation then becomes f of x equals the a value. Don't forget that you have to put the correct a value. X minus 3 squared minus 4. Because it's minus because of, it's the opposite sign for x. Then we have transformations. So the first thing we always do for transformations are the horizontal stuff. So again, this is a shift right 3. Then we have a vertical stretch or expansion by 2. And then we have it shifts down 4. Okay, so we're just putting everything together. Yesterday you learned how to get the vertex. Today we're putting it in vertex form. For today, for 5 and 6, identify the x and y intercepts. Well, in order to do that, we have to factor it if we can. This one I believe is factorable. Let's check. And I always guess and check with these. Since it's multiplying to 2x squared, we know one of these has to be 2x and one of these has to be an x. Since it's multiplying to a negative 5, it has to be a 5 and a 1. I'm going to do some quick guessing. If I put a 5 here, a 5 and a 2, there's no way I can get a 9 out of that. The 5 has to be here, the 1 has to be here. We need a positive 9, so that means that this has to be a positive 5 times 2, which is a positive 10, and then that's our minus 1. So that would be the correct form. To find the x-intercepts, you have to set y equal to 0 in this form. And when you solve both of them, you get that x is equal to 1/2 and x equals negative 5. So our x-intercepts are the points 1/2, 0, and negative 5, 0. The y-intercept is just when x is 0. That's when, so that's f of 0. And you just get 0 plus 0 minus 5. So the y-intercept is 0 comma negative 5. You just put a 0 and it cancels both those out. You're good. We can actually do the y-intercept really quickly. When it's in standard form, the y-intercept is always the c value because the zeros will cancel out the x. So the y-intercept for this one is f of 0 is 2, so we get the point 0, 2. All right, let's get the x-intercept now. This one is not factorable. It's just one of those things where it doesn't work out when you try it, and I don't want to go through that, but it's not factorable. So what you can do is use the calculator to graph it to find the x-intercepts. All right. So when you do that, you get something that looks kind of like this. Okay. And when you put in second trace 5 with or second trace 0 for these two, you get that the x-intercepts are 0, comma negative 0.457 and a positive, except for these are x-intercepts. Therefore, it should be her x-coordinates that are first, negative 0.457, comma 0, and 1.457, comma 0. That's what you get for those 2 points. Okay? All right. Graph the following quadratics, plot, and determine the increasing and decreasing intervals. All right, the easiest thing to do for these is to find the vertex and then go 1 or 2 points over from there. So the vertex, by this definition, because it's in vertex form, is negative 1, negative 3. So we know at negative 1, negative 3 we have this. We also know it's opening up because it's positive. So what I would do is make an XY chart, negative 1, 0, and 1. I'll just do those. And we know what negative 1, we're at negative 3. So now just plug in 0 and 1 into here. If I put a 0 in, I get 1 times 2 is 2, minus 3 is negative 1. If I plug a 1 in, you get 1 plus 1 is 2, squared is 4, times 2 is 8, minus 3 is 5. So I know that my other 2 points are 0, negative 1, and 1, 5. Now, remember, since these are symmetric, negative 2 will be at negative 1, and negative 3 will be at 5 as well. That's why you don't have to do more than that. So there's a nice, look, I messed that up, but that is the quadratic for that one. And then it says state the increasing and decreasing intervals. Well, it's increasing on the second part of the branch. And remember, this is the vertex at x equals negative 1. So it increases from negative 1 all the way to infinity. It decreases from negative infinity up to negative 1, this branch. Okay, so it's going to have one branch and then the other. All right, next we have to have the vertex for this. It looks like it moves 2 right and then it doesn't move up or down, so the vertex is 2, 0. So if I do an XY chart for this one, I'm going to start when x is 2 and then I'll do 3 and 4 as well, and y will be 0. When I put 3 in, I get negative 1/2. And when I put 4 in, 4 minus 2 is 2 squares 4. Half of 4 is negative 2. So it looks kind of like this, 2, 0. 3 negative 1/2, so it's barely moving. 4 negative 2, which means that 1 will be at negative 1/2 and 0 will be at negative 2. So it's kind of more, it's more compressed, which makes sense because the a value is 1/2 instead of 1. Okay. Now we can get our increasing and decreasing intervals. It is increasing at the beginning from -infinity, and I'm writing it in the wrong spot, from -infinity to, that's an x value of 2, and it's decreasing from 2 to infinity. Again, we're dealing with only the x values. All right, last two problems for the day. I know these notes are a little longer, but it's a lot of good problems with quadratics here. We're going to come up with the equation, which means we need to know what the a value is. We have a vertex and a point, so the first thing you should always do when you have a vertex is write it in vertex form. Okay? So let's do that. I get f of x is equal to a times x plus 2 squared, because it's a -2, and then -2. That's the starting point for that one. And if we go over here, you can do the same thing for this problem. A, the vertex is at 1, so it's x minus 1 squared, because it was a move right, and then plus 5. So now what you have to do is take the other point and stick it into x and y. So the point is going to go here, the y, when y is 2, x is 0. And then we can solve for a. So we get 2 is equal to 2 squared is 4a minus 2. 4 is equal to 4a, which means a is equal to 1. So the last step is take that and just rewrite it into the first one. F of x equals 1 times x plus 2 squared minus 2. So that is the function in vertex form, that you found a quadratic in vertex form. Let's do the last one. When y is 3, x is 0. So this becomes 1a. And subtract 3 or 5, and you get -2 equals a. Which makes sense because this graph is narrower, it's stretched more, and it is facing downward. So it should be that. So then we write it out with the a in there. -2, x minus 1 quantity squared plus 5. Okay, so I know that was a lot. These are really good problems to know how to do. And we will finish up quadratic stuff day 3 tomorrow, and we'll go from there.